Hello, and welcome to the second module in a three-part series of modules regarding data. My name is Jordan, and I am excited to join you on this data and analytical journey. This data module, Aggregations, will walk through different data and analytical aggregations. As a result of this learning module, you will walk away with the following understanding. What are data and analytic aggregations? Learn about specific aggregation types like mean and median, and finally, learn why these aggregations are important in the world of analytics. As was mentioned, this is the second module in a series of 3 modules regarding data. If you haven't already viewed the first module, Understanding Data, we encourage you to do so as it will provide you more information regarding data. Our first topic to discuss in this learning module is what is an aggregation. By definition, an aggregation is a collection or gathering of things. When it comes to data, aggregation is the gathering or collecting of information, putting like observations and values together, and summarizing this information for various reasons such as reporting and analytics. To simplify, it means to summarize collected data, making it easier to use. The definition of aggregation is pretty simple. To help us see how aggregation impacts different aspects in the real world, we will review 2 examples. The first example we will look at is financial reporting. Companies produce financial results for a variety of reasons: accounting, analyst reports, earnings releases. Companies also release financial results at different time periods, for example, month end or quarter end. And those reviewing the numbers don't want to review every single transaction that occurred during the time period or periods being reported. They review summaries of all the data. Those reviewing the numbers receive an aggregation of the totals, which makes reading and understanding the data easier. Another example of aggregation in common use would be aggregating marketing results to see the overall results of a campaign. When a company wants to review a campaign to assess its efficacy, it would be difficult to understand how a campaign performed if the company reviewing the individual companies or persons had to review each individual data metric. This could take a large amount of hours to go through all the data points to determine how the overall campaign is doing. In this case, aggregations of data can be used to help analyze the campaign, which in turn can help the company assess strategy and direction of the campaign moving forward. Overall, aggregations help businesses to assess and process large amounts of data easier. This in turn helps a company with efficiency, strategy, marketing, and more. With these examples in mind, what are some common aggregations that are used with data? Let's take a look. The aggregations that we will cover are mean, median, mode, min, max, sum, and count. To help us understand these aggregations, we will be following a fictitious company named Jordan Analytics. Our company is a small business of 20 employees. The use of this fictitious company is to help us see real-world application of these aggregations, which can help make understanding easier. We also hope this example will help drive home the importance of these aggregations, how they work, and how they apply. Before we go into our first aggregation, one other key takeaway from this training is understanding how these aggregations can be misused or misleading. One of our goals through the analytics modules of the Click Continuous Classroom is to ensure we walk away from the trainings more data literate, and this means getting both the good and the bad of analytics. This will arm you with the ability to interpret and understand analytics better and what the numbers are truly saying. The first aggregation we are going to review is mean. Sometimes mean is called arithmetic mean. How often do we see the word average when looking at numbers? In baseball, think of batting average. Average miles per gallon when we are driving. Average test score while in school. These would be considered straight averages or a mean. The math behind a mean is straightforward. Summing up a total and then dividing it by the number of observances, you are calculating a mean. To understand the aggregation mean better, let's see how our hypothetical company used an average to market to job seekers. Our company, Jordan Analytics, wants to attract new data scientists to the company. The company wanted to promote the salaries of workers at Jordan Analytics. If we have 20 employees, how do we calculate the mean salary? This calculation will be straightforward. We sum up the total of the salaries of employees and divide it by the total number of employees, 20. Let's say in our example the sum total of all salaries is $3,049,000. If we divide that total by 20, we get our mean salary of $152,450. That sounds like a great mean salary, doesn't it? I would say so. But herein lies a problem when it comes to mean. While we are okay with the fact that $152,450 is the mean salary, and it has absolutely been calculated correctly, does it truly paint the correct picture of salaries in the company? Does it tell the whole story? Let's take a look. If we look at a chart of the salaries of each individual employee, what do we see? Remember, our average salary is $152,450. But how equal or fair is the pay throughout the company? Looking at the chart, we can see how the individual salaries are distributed, compared against each other. The chart shows that 3 employees are making significantly more money than the mean, but the rest are below the mean. In a company of 20, that would say only 15% of the company is making more than the average, while 85% is below the mean. Isn't that interesting? Herein lies a problem with mean, and a potential way to mislead or misuse with this aggregation. A promotional advertisement recruiting job seekers with an average salary of $152,450 would look like a great job. But if only 3 of the 20 employees of the company make that salary, and a large majority are below the mean, it might not be as appealing as it looks on the surface. Remember, in analytics, we want to be skeptical of what we see. We want to ask questions, and we want to get to the why behind the numbers. Now, knowing this information about the company, and knowing how the mean looks to be skewed and affected greatly by the 3 large salaries, the question then can be, if we don't look at the mean, is there a better aggregation to use? Let's jump into the second aggregation type we will cover in this training, median. When thinking of the aggregation type median, think middle. The median will find the middle number in your data. A quick example is the data set of 1, 2, 4, 5, and 28. If you look at this data, put it in order, we can see the middle number is 4. That is our median. If we look at the mean of these numbers, that answer is 8. If you have an even number of data points, say 2, 2, 4, 8, 10, and 18, then to get the median, you take the middle 2 numbers and add them up and divide by 2. In this case, we would get 6 as the median. To help us understand median and its descriptive capability better, we will use our company, Jordan Analytics. Looking at the chart, what is the median salary of employees? The median salary for employees is $42,000. That looks quite a bit different than $152,450. From this chart, we can see the gap between the two, mean and median. Let's review how the median was determined. Looking at the table of employee salaries, are we able to tell which salary is right in the middle? Looking at the table with the salaries not in order, it can be difficult to find the middle number. In today's world of large amounts of data, computers help us with the complication it would be to order data and find the median. With our example, let's adjust the numbers so that we can see the middle salary. Remember, since we have an even number of observations, we will find the middle 2 numbers, then divide by 2. At Jordan Analytics, the middle 2 salaries belong to Michael at $42,000 and Tara at $42,000. Since they are the same number, adding them up and dividing by 2 won't change the answer. The median salary is $42,000. Is this a better representation of the company's salaries? In this case, it appears it is. A couple of notes regarding the median. The median number does not have to be a number that appears in the data set we are using. For example, let's say your observations are 1, 3, 5, and 7. There are 4 numbers, so you would add 3 and 5 together, which is 8, and divide by 2 to get 4. 4 is not one of our observation points, but that does not matter. The median is 4. The other thing of note is it doesn't matter that some of the observation values are repeated. Let's review the following observations: 1, 1, 3, 3, 7. The median number is 3. One question you might be asking yourself: when would I use mean over median, or vice versa? To answer this question, we need to look at the data itself. If when you look at your data, and the data lies in a normal or close to a normal distribution, i.e. does not have outliers that can skew the results, then the mean can be an appropriate analytical tool to use. On the other hand, if your data contains observations that can skew the data, this would direct us to use median. Looking at our chart, we can see there are 3 data points that are outside the normal trend of our salaries. This drove our mean up to $152,450. The median salary in our data is $42,000. The median of $42,000 would better represent our data. This concludes part 1 of a 2-part video. Please close this browser window, return to the interactive video section, and click the link to launch part 2.